we're going to move on to our next speaker, Sam Lawrence, who will give us a summary of league outcomes that are related to Regolith investigations. Take it away, Sam.
Good morning. Again, hopefully everyone can hear me. I'm using a different speaker today like everyone else. I see Eddie nodding. Great. Okay. Yep. So I'm here today to talk about some of the league outcomes relating to Regolith that have happened over the past few years. Next slide, please. All right. So starting around 2016 or so, League on behalf of the community started preparing for what we all thought might be a new era of lunar exploration. So we executed some updates to the lunar exploration roadmap to discover, define objectives, feed forward applications to small bodies. We executed Back to the Moon workshop in 2017. And then we did a polar volatile coordination study on the behest of the International Space Exploration Coordination Group. And of course, there was the fantastic Survey League Lunar Science for Landing workshop in January of 2018. The biggest one of those was the Advancing Science of the Moon report, which was a panel that had 30 people on it. It was the largest and most complicated thing League had ever done in terms of an in-person rapid action study, which produced two reports. One was the Advancing Science of the Moon report, and the other was the Next Steps on the Moon report. Both of them are being used for their intended purpose right now as guiding touchstone documents for the Artemis program. So what the organizers of this meeting asked me to do is summarize some of the outcomes relating to, from the ASMSAT report specifically relating to dust and regolith. Next slide, please. Okay, so there's a whole concept. So the point of the ASMSAT report, the Advancing Science of the Moon report, was to assess the scientific context of the exploration of the Moon report that was written in 2007 and see what progress had been made, particularly the impact of the Lunar Reconnaissance Orbiter mission, the Cassini of the Inner Solar System, which has been wildly successful and redefined more or less every single lunar science question. Along with some of the other missions flown by international partners and the LADI mission and other missions such as the Chang'e 3 missions, the Chinese landers. So there's a whole section in the SCIM report about regolith processes. And one of the findings of ASMSAT was that because the SCIM report was written in the context of the Constellation program and the Robotic Lunar Exploration program, a lot of the stuff in the SCIM report required surface exploration to address. The United States never actually carried out any surface exploration missions as part of the vision for space exploration. So there's still a lot of stuff left to be done. So if you look at the SCIM report regolith section, it's all still valid. And then what the ASMSAT team did was they went through and they high-graded some of the results. So, so for goal 7A from SCIM, to search for and characterize ancient regolith, that requires subsurface drilling and sampling. For goal 7B, determine the physical properties of the regolith, that requires geotechnical measurements from precursor missions. For goal 7C, we have understand regolith modification in the presence of volatile materials, that requires sample return from the polar regions. And for goal 7D, separate and study rare materials in the lunar regolith, that requires we hear a lot about, conflicts between science and resource processing, but they're synergistic. They're not mutually exclusive. You have large-scale ISRU processing of Mare regolith in the titanium-rich regions to produce oxygen. You might pick up extra lunar materials and be able to identify those through large-scale ISRU processing to produce resources. Next slide, please. For concept date for the exosphere, to determine the size and spatial distribution of any electrostatically transported dust, if it exists. We need to understand how and if electrostatically lofted dust operates, and so that means a long-lived sensing and detection station on the surface, some sort of deployable geophysical network and associated power infrastructure supported by orbital assets to provide global context. Next slide, please. Okay, so how do we make progress? Subsurface measurements, drilling, start doing large-scale ISRU processing and resource production, make geotechnical measurements using astronauts and uncrewed precursor spacecraft, do long-lived uncrewed rover operations, deploy a stationary geophysical network, and also deploy a lunar exosphere monitoring station. So that was sort of the outcomes from the ASMSAT report, and I'm exactly done in 5 minutes.
All right, thanks, Sam. Ben Greenhagen does ask, can League and Survey team up for a second landing site workshop because the first one was awesome? Oh.
Good question. We'll take that up for future work.
Sounds good. All right, thanks, Sam.